Next we look at freely falling bodies. We try to see what are freely falling bodies and why are they studied as a special case of a uniformly accelerated motion. Okay, so let's try and understand this. Let's say this is the earth's surface. So this becomes the ground for us, right? And let's say there is a body which is held at a certain height, h, which is a small height only, not a very big height, especially when we compare this height h with the radius of the earth. I hope you all know the radius of the earth which has a value of 6400 kilometers. In comparison to this number, if this height is quite small, which means that we are keeping this body near to the surface of the earth itself. In that case, it is found that as this body is dropped from this particular height and as it falls down, if we assume that there is no air resistance in this region, which is an idealized case, but this is how we study it for now. And the second thing is, if we assume that h is much less than the radius of the earth, then it has been found that as this body falls down, it has a constant acceleration whose value is equal to 9.8 meter per second squared in the downward direction. We know that the body accelerates down. No? As it moves down, its speed increases. Yes. So it's found that its speed increases at a rate of this, which is also called as the acceleration due to gravity, denoted by a letter small g. Okay, and this acceleration due to gravity always acts towards the surface of the earth. It rather acts towards the center of the earth always, which in this particular case, as we look at the figure, is towards the ground, right, downward. So we say that in case this condition is true, that there is no air resistance and h is quite small in comparison to radius of the earth, then this body will fall down with a constant acceleration of g, 9.8 meter per second squared. Sometimes you might find this value of g to be mentioned as 10 meter per second squared also. This is done for the sake of convenience of mathematics. The same thing happens if you throw a body upward from the surface of the earth. Let's say if you throw it vertically upward with a certain initial velocity, in that case also it is found that the body, as it moves up, it slows down because the earth is pulling it down, and the rate at which it slows down, the rate at which its speed decreases, is also the same, g in the downward direction, acceleration due to gravity in the downward direction. So do you see that both these cases are that of freely falling bodies? A body which is free to move under the effect of earth's gravity once dropped from a certain position above the earth's surface, or when it is thrown from the earth's surface in the vertical direction, or for that matter we shall see later that this is possible even if we throw the body with some angle also at some direction, in some direction. Okay, now if not vertically upward or vertically downward, even if it moves in a certain plane, then also the acceleration acting on it will be a constant having a value of g in the downward direction. Okay. So this is the reason why we say that a freely falling body will always have a uniformly accelerated motion. Okay. So if we take the upward direction as the positive y direction, then understand that the acceleration acting on the body will be along the negative y direction, then we will take it as minus g. Whereas if we take the downward direction as the positive y direction, which we can do, it's up to us, it is according to our own convenience that we can choose any of the directions, positive or negative. In that case, the acceleration, because it is acting in the positive direction itself, we will be taking it as positive. So here in this case, a will be minus g, acceleration of the body, and if we take the downward positive, then a will be plus g. Now it depends. Okay, and once we have chosen the positive direction, accordingly we take the value of acceleration, positive or negative, right. So this is why we consider freely falling bodies as special cases of uniformly accelerated motion, and understand that since this a, which is equal to g equal to 9.8 meter per second squared, is a constant, we can use the equations of motion. Equations of motion can be used in case of a freely falling body, in the process of studying a freely falling body, we can always use equations of motion are applicable. Why? Because if you remember, the equations of motion are valid only for uniformly accelerated motion, only when acceleration is a constant. Since in case of a free fall, acceleration is uniform, we can say that we can use the equations of motion. So, how do we use the equations? Let us look at that as well. V is equal to u plus at, the first equation of motion. A will be replaced by G with a positive G if we take the downward direction positive, and with a negative G if we take the upward direction positive, isn't it? S is equal to ut plus half at squared. Here also you can put A is equal to G with a plus sign if you take downward direction positive, and with a minus sign if you take upward direction positive, and exactly the same thing in the third equation also, v squared minus u squared is equal to 2as. Okay, so all these three equations now are valid in case of a freely falling body, with a small condition that A has to be replaced by G. So, to understand this better, let us take up a few examples now. The first example, a ball is thrown up from the ground like this with an initial velocity of 40 meters per second. Okay. The question is, you are supposed to find, number 1, the time that the ball takes to reach its highest position. Do we understand that as this ball moves, its speed decreases till it reaches the highest point, where if we try to find out the condition, understand that at the highest point the ball will stop for a moment before it starts moving down once again. So, when it reaches the highest position of its path, its velocity at that point will be 0. This is one thing that we all need to understand. So, we are supposed to find out the time that it takes to reach the highest point. That means time when its velocity becomes 0, right? That is when it will be at the highest point. Second part of the question asks you to find out this corresponding height, the maximum height that the ball attains. So, both these things we have to find out. So, let us work on this. Since the ball has been thrown upward, if we want, we can take the upward direction positive. Okay. When we take the upward direction positive, understand that the initial velocity of the ball will be 40 meters per second, upward, hence positive, right? Then the acceleration of the ball, let us take the value of acceleration, which in this case will be g. Understand that as the ball moves up, g will act on it in the downward direction. So, since we have taken upward direction positive, a has to be minus g, which for the sake of convenience of mathematics, let us take it as minus 10 meter per second squared. Okay. So, generally in the questions they will tell you to take the value of g as 10 itself. If it is not mentioned in the question, you are supposed to take the more accurate value of g, that is 9.8 meter per second squared only. Fine. So, for the first part of the motion, can we say if the velocity of the body becomes 0 at the highest point, in order to find out the time, we can use v is equal to u plus at, the first equation of motion, to find out t, because we know all the other values. So, this would imply v, which is 0, is equal to u, which is 40, plus a, which is minus 10 into t. So, when we solve this, we will get t is equal to 40 by 10, which will be 4 seconds, right. So, this ball takes a time of 4 seconds to reach from the bottommost position A to the topmost position B. Once it reaches B, understand that it will start falling down once again, isn't it, and will reach back the point A. In fact, you can prove that it takes the same time back to come down from B to A also. Now, for the second part of the question, to find out this height that the ball travels, we can maybe use the second equation of motion to get the displacement from A to B, that is nothing but the height, right. So, S is equal to ut plus half at squared will give us the value of h. S becomes h, the displacement of the ball from A to B will be h, is equal to u, which is 40, We know the value of t now, which is 4, plus half a, which is minus 10, into t squared, which is 4 squared, right. So, we can solve all this to get our final answer here. When you solve this, you will see that the value of h will come out to be 80 meters. You can just check the calculations. So, we get the height of this ball also, the maximum height. Let us look at another question now. This time a ball is dropped from a height of 20 meters above the ground. So, this is the situation now. The ball is dropped means someone held the ball in their hand at the height of 20 meters and then they just release the ball from there. So, understand that this means that the initial velocity of the ball would be 0. The ball will start from rest, right? Okay. So, for this particular situation now, we are supposed to find out the speed with which the ball hits the ground. So, v when the ball hits the ground, that is the first part, and as the second part we are supposed to find out the position of the ball at half the speed. Position of the ball at half of the above speed, the speed with which it hits the ground, right. So, for the first part, to find out the answer to the first part, do we understand that as the ball reaches the ground, just before hitting the ground, it would have travelled a total distance of 20 meters downward. So, for the first part, we can take the displacement of the ball as 20 meters in the downward direction, right. What else do we know here? We know that the initial velocity of the ball is 0. Yes. We also know that the acceleration acting on the ball is g in the downward direction. So, g downward, and we are supposed to find out the v, the velocity when it reaches the ground. See that here two quantities are already in the downward direction. So, it makes sense if we take the downward direction positive this time. This will help in calculations. We do not have to take too many minus signs in the with the terms, right. So, let us take the downward direction positive. As soon as we take the downward positive, now our acceleration becomes plus g, it is not minus g anymore. Though understand that you can do the same question considering upward direction positive also. It will just make a few terms negative, but then it will so happen that the minus sign eventually will cancel out throughout the equation. So, you will still get the same answer. Here, just for the sake of convenience, we are taking downward positive now. So, which equation will connect these terms here? U, V, A and S, the third equation of motion, isn't it? V squared minus U squared is equal to 2AS. V we are supposed to find out, V squared minus U we know is 0 is equal to 2. A, which is G, which we can take as 10, and S, the displacement downward, which is 20. So, it is simple for us. V squared we are getting as 20 into 20. Right, let us write it as 20 into 20 itself, because then when we write V, it will be simply 20 meters per second. So, the ball hits the ground, the moment it hits the ground, it hits it with a speed of 20 meters per second. Now, position of the ball at half the above speed. So, where is the ball when its speed is half of this maximum speed? That is 10 meters per second. Let us assume that the ball has travelled a certain distance y in the process of reaching a point where its velocity is 10 meters per second, half the maximum speed. So, what we can do is we can once again use the third equation of motion, because now we know that we are looking for v being 10 meters per second, u we know is still 0, a is still g, which is 10 meter per second squared, and we are looking for the position. That means, if we can just find out the displacement of the ball from the topmost point to reach this particular position that we are looking for, S is what we are looking for, isn't it? So, we can once again use the third equation of motion, v squared minus u squared is equal to 2as. This time will give us 10 squared minus 0 is equal to 2 into 10, which is the value of A, into S, the displacement. So, we are getting 100 is equal to 20 S, or S is equal to 100 by 20, that is 5 meters. So, see that the position where the ball has reached, where its velocity is 10 meters per second, is 5 meters below the point from where it was released. So, why the displacement is 5 meters. Okay, this is how we can answer this particular question. Fine, let us take up another example now. Example 3 is, a ball is thrown up with a speed u from the ground, let us say. We are supposed to draw the graphs now. Draw graphs of A versus t, acceleration versus time, this is the first part. Second part is v versus t, velocity versus time, and C is S versus t, displacement or distance traveled versus time. Displacement we can look at for here for now, for one cycle of its upward and downward motion. So, we understand that as the ball moves up, it will reach a highest point where it will come to a momentary rest, and from there it will turn downwards and will reach back to the same position from where it was thrown. So, this is one cycle of the upward and the downward motion of the ball. For this one cycle, we are supposed to find out, or we are supposed to draw these graphs. Also, we are supposed to do this after considering the upward direction as positive. Upward direction as the positive y-axis. Okay. So, let us see to this. Understand that as the ball moves up, as it is going up, at any point in time, the acceleration acting on it will be g downward when it is moving up. And when it is coming down, in the downward motion, also the acceleration acting on it is g only in the downward direction. So, do we understand that the acceleration of the ball throughout its motion is g downward? There is no change in the value of acceleration throughout this motion, no, throughout the cycle. So, can we say that when we try to draw the acceleration versus time graph, in fact, we should take the timeline somewhere here, because now we know that acceleration is in the downward direction, so negative, because we have taken upward direction positive. Acceleration here is minus g and it is a constant throughout the motion. So, how do we depict this? We can just draw a straight line over here parallel to the time axis, whose value is minus g. Do you all understand? This will be the acceleration time graph. Acceleration is a constant all the time and its value is minus g, right? Now, let us come to the next graph, which is the velocity time graph. The velocity time graph, understand that we are talking about the vector v, mind you, not the scalar value. We might talk about the speed versus time graph as well, but for now we are working upon the velocity versus time graph. Maybe we can discuss the speed versus time graph also after this. So, for the velocity, see that which equation will work, v versus t, the first equation of motion, v is equal to u plus a t, which in this case will be u minus g t, right? We know that as the ball moves up, its velocity continuously decreases till it reaches the highest point where its velocity becomes 0 for a moment, right? And this rate of decrease of velocity is constant because acceleration is the constant, right? So, can we say that for the upward going motion, when the body is going up, its velocity, if the initial velocity given to the body is some u in the upward direction, this is positive u. As the body goes up, its velocity comes down and approaches the 0 value. It reaches the 0 value in a certain time. What is this time? This time, let us say, is the time that the ball takes to reach from position A to position B, the lowest position to the highest position. Can we say that in this much time, the velocity of the ball will become 0? So, this is that point here. At capital T, the velocity becomes 0. This is the point where the ball has reached the highest point of its trajectory, the path. What happens after this? After this, the ball starts moving down. The ball starts moving down means its velocity now becomes downward, which according to the direction we have taken, it is negative now because we have taken upward direction positive. In the process of moving down, the ball will have a negative velocity. And as the ball moves down, this velocity increases continuously in the negative direction. So, understand that after this, the graph will further move down here along the negative v direction like this. And what happens to the ball after another time interval capital T, after reaching the top, when it further moves for t, capital T, that means here at a time of 2t, understand that by symmetry we can say that the ball will gain the same speed when it reaches back, but in the opposite direction. This can easily be proved that if a ball is thrown up with a speed u, as it goes up and then comes back down, it will come down with the same speed u. The direction will be opposite, of course, of the velocity, but the magnitude of velocity will be the same. So, it reaches to the ground with minus u velocity. Okay. So, this is the graph for velocity versus time. There are a few things to observe here. See that this is a straight line with a constant slope. It makes one fixed angle theta with the time axis, which essentially tells you that the slope of the velocity time graph is the same throughout, and we know that the slope of the velocity time graph gives us nothing but the acceleration. So, which is true, we know that the acceleration of this ball is a constant throughout, right. So, the ball moves all the time with a constant acceleration is also verified from this graph, the velocity time graph, right. So, one common question could be, how will this graph change if we have to draw the speed versus time graph instead? Understand that speed cannot be negative, speed cannot take negative values, but the magnitude of velocity will be the same as the magnitude of speed at any point in time. So, understand that if we have to just change this graph to speed versus time instead of velocity versus time, all we need to do is the values of v which are negative, you just shift them to the positive side. So, this is not vector v now, it is simply v, speed versus time. So, the speed of the body comes down to 0 as it reaches the topmost point from u to 0 at a time t, and then when the ball starts coming down, the speed once again increases and reaches the same value u after another t. So, at 2t the speed will be u once again. I hope everyone is able to understand this. So, this is the difference between the velocity time and the speed time graph for the same ball being thrown up. Okay. Now, the next one that we are looking for is the displacement time graph of this ball. For the displacement time graph, we need to be a little more careful because the equation that governs the displacement as a function of time is not a linear equation. The equation that you have now is s is equal to ut plus half a t squared. It is a quadratic equation, in fact a parabolic graph we will have here. So, let us try to draw this graph indirectly as in we try to understand a few things regarding graphs and then we use those to draw this graph. So, what do we know about the displacement time graph? Do we know that the slope of a displacement time graph gives us the velocity of the body at that instant, right? So, the body starts with an initial velocity u. As it goes up, the velocity decreases. In fact, at the highest point, the velocity becomes 0 for a moment, and then it starts coming down once again and its speed increases once again and becomes u, but in the downward direction now. So, negative velocity it will gain. Yes. So, this time see how the graph will look like. Initially, the slope of the graph should be u, a high velocity with which the ball is thrown up. As the ball moves up, the slope of the graph decreases. As it reaches the highest point, the slope of the graph becomes 0. So, the graph becomes flat, parallel to the time axis, and then it starts coming down because the velocity becomes negative now, and let me draw it again, like this it will look. And by the time it reaches down over here, it will have the same speed but with an opposite direction. So, whatever angle the tangent makes over here at the starting point, whatever is the slope over here, you will have the same slope but in the opposite direction over here. So, this angle and this angle would be the same. Initial slopes will give us the initial velocities. Understand that it is at this point where if you draw a tangent, that tangent will be absolutely parallel to the time axis, telling you that here the velocity of the particle is 0, the ball is 0, that means the ball is at its highest point right now. Okay, and at any middle point over here or over here, as you draw the tangents, you will see that their slopes are decreasing, their inclination is decreasing. That is telling us that the velocity of the body is decreasing. So, see that this graph is not a straight line graph, it is rather a curved graph, like precisely it is a parabolic graph, right, and it tells us how the ball moves up and then it comes back down to the same position from where it was thrown.